Math Studies, Paper 2, and this is the last question of the November 15 paper. Question 6. Yukata makes a toy spaceship. It has 3 separate solid parts, a cone, a cylinder, and an hemisphere. This toy is represented by the following two-dimensional diagram. The cylinder is also shown in a separate diagram. The cylinder has a height of 15 centimeters and a diameter of 8. First question, find the volume of the cylinder. That's a simple question because if we go to the formula booklet, we can see that we have the formula of the volume of the cylinder. The volume of the cylinder is pi r squared times h, where r is the radius and h is the height. They are telling us the height, and they don't tell us the radius, but they tell us the diameter. So if as soon as we divide by 2, we have the value of the radius. So I do the sketch of the cylinder. I can write down that the height is 15 centimeters, as they tell me. The radius is the diameter divided by 2, so 4 centimeters. And I write down the formula of the volume of the cylinder, pi r squared times h. I just need to put the values. Pi, r we say is 4 square, and h that is 15. Putting all these values in the calculator, I can see that the volume is 753.9822. Remember, we want 3 significant figures for the answers in IB. I'm gonna write down 554. What are the units? Centimeters, but it's a volume of centimeters cube. Next question, the cone has a diameter of 8 centimeters. Yeah, that corresponds to the same 8 centimeters of the cylinder, it makes sense. And a volume of 85 centimeter cube. Find the height of the cone. They're asking me about this line here, this height here, and I know the diameter of the cone. This question is a bit more difficult, but not extremely difficult, as we go to the formula booklet and we see that we have the volume of the cone. And with the volume of the cone, it depends on 1/3 pi r squared times h. We know the radius because they give us the diameter, but they're asking us about the h. So we need to isolate the h. Now they're also giving us the value of the volume. So we just need to use the formula and isolate the h. I draw the diagram of the cone. I know the radius from before, half of the diameter that they tell me. The height is a question mark. I don't know, it's what I need to find out. But I know the volume, that is 85. So if I use the formula of the volume of the cone, 1/3 h pi r squared, I know that is equals to 85, they tell me, and I just need to isolate the h. So it's going to be 85 in the numerator, r squared comes to the denominator, pi comes to the denominator, and the 3 goes up in the numerator. So that's the formula I'm going to use. I just need to put the values. By the way, the radius is a 4 square. So let's put this like a big one. I put this in the calculator with my radius square as 16 is 5.07306. Remember that we are only interested in 3 significant figures. So I stay with the height is 5.07 centimeters. That will be the answer. Next question. The toy spaceship's total height is 24.6. I can see this in the diagram. Find the volume of the hemisphere. So what's the volume of this hemisphere? They don't tell us a lot about the hemisphere, isn't it? I don't know what is this diameter of the hemisphere, but I know how much is this length, isn't it? So this one that is gonna be the radius, I know because I know what is the total and I know how much is this part. So from here I can get what is the this height, which is no other than the radius of the hemisphere. That's the first thing I will need to calculate. Don't forget the 15 of the cylinder. So I can say that the total height is the height of the cone plus the cylinder plus the hemisphere. I know the total, I know the value, the height of the cone, I know the value of the cylinder, and I want to calculate this height of the hemisphere, which is going to be the radius of the hemisphere. I just doing the 24.6 minus all those values. The value you get is 4. That gives me a value of the radius of the hemisphere of 4.5269 and so on. If I'm interested only in 3 significant figures, is 4.53. So 4.53 is here, but remember what I'm interested is in the volume of the hemisphere. So here I need to recognize that this height is the radius of the hemisphere. And then I need to go back to the formula booklet in which I know what the volume of a sphere is, 4/3 pi r cube. So that only depends on the radius, and now I know the radius. And just be careful that we have a hemisphere, so we need to work with half that value. So recognizing that I need to work with half the volume of the sphere, because it's a semi-sphere, so it's 1/2 of 4/3 pi, and my radius cube. I need to put all those values in the calculator, and I get the answer of 194.2995 and so on. Remember, 3 significant figures, 194 centimeters cube will be the answer. Yutaka decides to paint the cone of the toy spaceship. So just the cone. Calculate the curved surface area of the cone and give your answer to the nearest centimeter square. So one important thing is be careful, because I don't need 3 significant figures. They are asking me to the nearest centimeter square, and I need to know what's the surface area of the cone. Again, I think this is an easy question because we have this information in the formula booklet. If I look at the formula booklet, all the volumes, and here I have surface area, the area of the curved surface of the cone. Here it is. The area is pi r l, where r is the radius that we know, and l is the slant height. The slant height we don't know, but we are going to be able to find it. That's the diagram of the cone with the r that we know, the height that we also know, but we have a value that we don't know, the slant height, L. So I may take this outside and draw the triangle we form here. We have the radius, we have the height, and we are looking for this slant height. Now we have these 2 values, and we see that is a right angle triangle, so we can just use Pythagoras. What is the hypotenuse? The slant height is square root of 1 of the leg, radius square, plus the other leg square. So that's gonna be something easy. If I remember, the radius was 4, and the height, we found it in one of the previous questions, 5.07 square. Everything under square root of obviously. So putting this in the calculator, I can see that my slant height that I need is gonna be 6.4579 and so on. I just want 3 significant figures. 6.46, that's the L, and I need this value for the next part. Going back to the formula booklet, the area I'm looking for, the curved surface of a cone, is pi, r, and l. So now I have the l. I'm just going to plug all the values I have in the formula. So the curved area of the cone, pi r l, I have an r, the r is 4, the l is 6.45. Putting all this together is 81.1830. I just need 3 significant figures so I can approximate my my answer to 81.2 is an area, so it's centimeters squared. And that's the final answer.